Have you ever wondered where the copper in your phone, your car, or the wires in your walls comes from? It all starts here, in a place of monumental scale. This is an open-pit copper mine, a massive terraced landscape carved out of the earth by some of the largest machines on the planet. From up here, these giant haul trucks look like tiny toys, but each one can carry hundreds of tons of rock. It's a breathtaking sight, a testament to human engineering and our relentless quest for resources. Today, we're going on an incredible journey to follow the path of copper. From raw rock buried deep in the earth to the gleaming, pure metal that powers our modern world.
The first step is raw, powerful, and noisy, gigantic electric shovels with buckets big enough to scoop up a car, claw into the earth, digging out tons of copper ore with each bite. This isn't shiny metal yet, it's just rock, containing only a tiny percentage of actual copper once scooped. The ore is loaded onto those colossal haul trucks. These behemoths navigate a complex network of roads, hauling their precious cargo from the pit floor up to the processing plant. It's a continuous, round-the-clock operation. A mechanical ballet of immense power. All to unearth the building blocks of our technological society once the ore reaches the processing plant. The real transformation begins. The first order of business is to break it down. The huge rocks are dumped into primary crushers, powerful machines that act like giant mechanical jaws, chopping the boulders into smaller, more manageable pieces about the size of a baseball. But that's not nearly small enough. From the crushers, the ore travels on conveyor belts to enormous grinding mills. Inside these rotating drums, steel balls or rods tumble with the ore, pulverizing it into a fine, sand-like powder. This step is crucial because it liberates the tiny copper mineral particles from the surrounding waste rock, preparing them for the next stage of separation. Now for a bit of chemistry magic. This fine powder, called pulp, is mixed with water and special chemical reagents in large tanks. This process is known as flotation. Air is then bubbled up through the mixture. Here's the clever part. The chemicals make the copper mineral particles water repellent, so they stick to the air bubbles and float to the surface, forming a frothy layer. This copper-rich froth looks like a bubbly, metallic mud. It's skimmed off the top, while the waste rock, or tailings, sinks to the bottom through this elegant process. We've concentrated the ore from less than 1% copper to a much richer concentrate of around 30%. With our concentrate ready, it's time to turn up the heat. A lot. We're now at the smelter, a place of intense temperatures and molten metal. The copper concentrate is fed into a massive furnace and heated to over 1200 degrees Celsius. That's hotter than volcanic lava. At this temperature, the concentrate melts and impurities begin to separate, forming a slag layer on top. The heavier, molten copper mixture, now called matte, sinks to the bottom. This molten matte is then transferred to another vessel called a converter. Here, high-pressure air is blown through the molten liquid. This causes a chemical reaction that burns off the remaining sulfur and other impurities, leaving us with copper that's about 99% pure. It's called blister copper because of the bubbly surface created by escaping gases as it cools. But 99% purity isn't good enough for high-tech applications. We need to get as close to perfect as possible, and that's where electrorefining comes in. The blister copper is cast into large plates called anodes. These anodes are then submerged in a huge tank filled with an acidic electrolyte solution. Thin sheets of pure copper, called cathodes, are placed between them. An electric current is then passed through the tank. This current causes the copper atoms from the impure anode to dissolve into the solution, travel across, and deposit themselves onto the pure cathode, one atom at a time. The impurities, including precious metals like gold and silver, are left behind, sinking to the bottom as a valuable sludge. And here it is, the final product after days in the electrolytic bath. The cathodes have grown thick with brilliantly pure copper. Now at an astonishing 99.99% purity, these gleaming, salmon pink sheets are pulled from the tanks, washed and stacked, ready for their journey. From this massive mine to these perfect plates, the process is a marvel of science and industry. This copper will soon be drawn into wires, rolled into sheets, and shaped into pipes. It will conduct the electricity that lights our homes, transmit the data for our global communications, and form the backbone of countless technologies. It is an amazing journey from a simple rock to the very metal that connects and powers our entire world. Thanks for watching, and if you enjoyed this journey, don't forget to like and subscribe for more deep dives into how our world works.